And it looks like I might survive it after all. In fact, I'm quite thrilled to see that there's still almost 70 people here that have stuck it out to the end. I was expecting to come with the final devoted dozen or something to this last hour. But now it looks like I'm going to actually have to give the lecture. Okay, several things happened in between. First of all, we had an overwhelming vote for changing DVI with respect to these XXX commands. So now the official DVI version 2 has XXX1, XXX2, XXX3, XXX4, and the postamble instruction is number 243 now. And so that is going to take place. Don't propagate this old definition of version 2 too far, because that just has a bug in it. You know, this cover to the guinea pig edition says that it has bugs in it, and nothing has been announced as version 1 yet or anything. So we can still make these changes. The official version 2 will have that in it for sure. Another thing I guess I should have mentioned last hour is the. I see there were several things that came up. People commented out. One is that a good idea for having these pointers in there that connect one BOP to the previous one is that you can skip around and just print a few pages of the file, and that's quite often people have a huge DVI file and they say, please, the paper wrinkled on page 98 or something, or would you please just give me page 98 again? And this makes it a fast way to skip through the file for such things like that if you can. Now, on the other hand, on IBM Pascal, it won't allow you to go conveniently from the end of the file, and they have been writing two postambles. They write the ordinary DVI file, and then they also write the postamble as a separate file, and it's easy, and on their particular system, it's just as well for them to pick up the postamble first from this short file, and then read the other one, and keep two files in tandem like that. But if they want to ship a DVI file somewhere else, they've got to have it in the standard format with the postamble at the end. Question?
That's not necessary in the IBM VM system. You just need the one file.
It's not necessary. It's a matter of preference in some places that they might want to do it, but they might. Yeah, okay, that's true. It's a. Okay, thanks.
Maybe it would be a good idea for DVI type to be called version 2, since it prints out version 2 DVI files.
Aha. Well, that's a thought. Now let's see. It was probably something else that I forgot about that I thought it would be a good idea to bring out. What was it? Oh well. There's a million things that I wish I could present to you all, but time is so short. Now, the subject of this last lecture was announced as initializing a working TeX production system, and we want to talk about that first and then clean up with all other questions answered. So as I mentioned several times, we've got a switch in the program code that's between init and tini is commented out unless you're writing a program, unless you're generating a version of TeX called anyTeX. Then, if you have, if this really is null, if these are both null, then you get anyTeX. If these are brackets, and in order to get it to come out in web, you put escape character in front of it to get the brackets. Then you get a program that's called virtex or vertex or virgin TeX. It's a version of TeX that is for production, doesn't have anything in it. It's tabula rasa. Its mind is clean, has nothing inside of it. Now, the only difference then is how you set init and tini in order to generate these two. you should probably make different change files that differ only in a few ways, but one of them to generate this one and one of them generate this one, unless you would prefer to edit the, maybe one of them you're generating, you keep your change file in one form and then edit it back and forth and write a little program to fix that or something. But since we don't have nested change files in our web system, we don't have a way to make a short change file and your big change file. So I've been just keeping two change files, and I don't change only these two things. I also change the sizes of tables. In my Initech, I don't have as large a mem size because I don't need it. I only need enough to read in my macros, not to actually use the macros. In Initech, however, I increase the size of my hyphenation tables because I don't know how many patterns I'll actually need. And then in Virtec, I'll know, from looking at different format packages, I'll know that I have enough room if I cut the hyphenation tables down. Now, Initech can do a few things that Virtec can't. It can write format files. It can load all the primitives into the hash table. It can load all the strings into the string pool. It can compute pattern, take patterns and pack them into this packed trie that we talked about yesterday. Those algorithms are commented out otherwise, and they would just be deadwood in a production version of TeX, because they only have to be done on these rare occasions when somebody is loading in a brand new format package that's supposed to be dumped out. Now, in order to make room for those, then you can decrease the mem size. But on the production version of TeX, well, let the mem size be as large as reasonable, so that you can make use of more, set larger jobs. I actually don't imagine that at Sale we'll actually be using either of these programs very often, because what will happen is when you run Virtec, then you will say some format that you will load, say AMSTEC, but let's say for first BASIC, and you will ask for Virtec BASIC. Here I'm showing it as a command line. I'll talk about command lines later. So Virtec, suppose I run Virtec and it gives me a prompt and I say BASIC, and then it runs through the BASIC file, and then I say dump. Oh no, Virtec, no, sorry. Let me talk Initech first. I'm getting ahead of myself here. Initech, 2 asterisks, and I start out and I say BASIC. Initech then reads in BASIC format. BASIC loads in a lot of fonts. It defines patterns for hyphenation. It defines a bunch of macros. It defines codes, math codes, del codes, UC codes, SF codes. For the math codes, tell what characters mean in math mode. SF codes are the space factor settings. The macros are going to be keyed to certain fonts, and so they'll work well with fonts. They'll say that your math greetings from Seattle. I just got the note here saying greetings from Seattle. I don't know what that says, but excuse me a minute. I don't know if knew that she was interrupting this class here. Well, the delimiter codes. Oh goodness, forget it. Okay, the delimiter codes would be tied to your font. So, for example, let's say that your left parenthesis is in a certain position in the font, so that you can start your searching for next larger and things like that. Now, the guy went to college with me. Lives in Hong Kong. He was a professor of mathematics at Iowa State for several years, but now he's decided to be rich instead. Okay, now that's that. No, okay. Computer mail is so easy to send. You get a lot of it, and so I've had my secretary screen it for me. But sometimes she doesn't know if I really want an urgent message or not. Basic will contain all that stuff, and so I haven't written Basic yet, but you can see what that it will have to have everything that depends on the fonts is going to be in there. It used to be predefined in TeX. In the present TeX, I'm embarrassed to say this, but there was a relationship between the kinds of delimiters that you had to have in different fonts. The left bracket, the left bracket, and the floor functions and so on in the symbols font had to be in exactly the same position in the extension font, except shifted over. That was ridiculous, but it was, at the time I designed that, I thought I was going to be the only user of the program. Now all of these things are freed up and they're all specified by tables. Basic is where those tables appear, so that anybody who uses the Basic that I supply, that'll be geared to the fonts that I supply also, just to be consistent. If somebody has another guy's fonts, they make their own analog of Basic. Okay, run Initech, and then it asks for Basic, and then after that, it might prompt us for the next thing, and we'll say dump. Dump prints out. Now it will then print out a bunch of messages saying that it's printing out file basic FMT, and it's going to be called basic FMT, and then today's date. So when TeX starts out, it would have said this is TeX Initech version something Initech, and then when this one starts out, it will say this is TeX and no format preloaded, and then we would say basic, and it would use the algorithm I mentioned earlier today to bring in this file, basic.fmt, and it would then have all that stuff, all the fonts and everything done. Now, on our system, this would save a great deal of time because this will mention about 20 fonts, I think, and to open 20 different short TFM files and read them in takes a bunch of time on our system. Reading one FMT file would be much faster. The time actually to enter all those primitives in the hash table is negligible. That was quite fast. 240 calls on the hash program. That wasn't too bad. To compute the patterns was taking about 8 seconds, according to the patterns that we showed yesterday. So that wasn't too bad. But so the thing we're really saving. Oh, well, we wouldn't want to do those 8 seconds every time, but we're saving maybe 15 seconds for loading those TFM files. And I don't know why, but it's when the time sharing decides to give service to the other people when we're opening a lot of short files on our system anyway. Now, Vertex is there then, and if you say basic, then you got it. The way the program is set up, if you didn't say basic, you would get basic because basic is the default. But imagine that this was some other thing besides basic. Now, on most on lucky systems, let's say, you can now save the whole core image and start from here and imagine a so you hit call or something here or say, and then you save the core image, and an operating system is able to swap you out at this point, and timeshare for other things on a lot of computers. So then it should be able to swap you in again tomorrow, and over again for each user. The capability is pretty much in there. The thing that the operating system worries about is your registers, getting them in a consistent state or something like that. But there's if you're lucky, there's a system that you can make that'll put this out on some dump file or exe file or some other kind of called file that you can load directly, and it's even faster to load this than to go through your linking loader. It takes disk space, but it's fast, and we don't even have to read in the font file. Now, If so, if you have that, then you could save it and call it TeX. Because the word TeX itself will be used in the user manual to indicate a version that assumes basic format. My user manual is going to be an introduction to the primitives of TeX as extended by basic format. And there will be a distinction between what's primitive and what's in basic. But it's not going to introduce anybody else's format module. But you can't use TeX without a format module very well. So basic is the one that it's going to talk about. Now, so that's the system we'll call TeX. If this, instead of basic, was, say, AMSTEC for the American Mass Society or whatever macro package you have, then we would save that and we would have AMSTEC. And somebody then who starts out, and so that's why I'm saying Initec and Vertec hardly ever would be called. People, the users out there, would be running TeX or AMSTEC or whatever the popular format things are at your place. That would be of some advantage just because they have less to type. It saves them a little bit, but on our system anyway, we would probably do it that way. It's not going to be true for everybody's system. Now, what's going to happen inside this Pascal program so that the Pascal program knows what to do at this point? Because the Pascal program doesn't just want to start out from this core image at this point. That would actually be a mistake. It has a date and time recorded in there, for example. That's no good. It's got a job name already recorded in it. AMSTEC, your job name would always come out called on amstec.dvi. So there are things that you want to initialize over again when you start running. Okay, well that's been explained in the program when we get down to the main program, which is there at part 51, module number 1197. And I'm going through the discussion here that's in 1198. There's a global variable that I call ready already. And this is initialized to when any of these programs start out and set the key global variables to values, then ready already gets set to a sort of a strange constant 314159. Under the assumption that it's very unlikely that it already happened to be that when the loader finished with the program. Now, some Pascals will be cautious and they will put a special flag value into variables so that if you make the mistake of using a variable before you have assigned it a value, then it gives you an error message. And so that would destroy this because I am breaking the rules of Pascal. The very first thing I do after opening the terminal for output is ask if ready already equals 314159. If it does, then I assume everything is okay, and I jump right into the beginning of the program. Otherwise, I go through the whole initialization procedure that will do prompting and things like this for format files. Now, these systems that protect you against such sins also probably, they allow you to turn off this protection. As soon as TeX is debugged, we won't need that protection anymore. So you would be able to turn it off and still use this kind of a hack. But this is a way that works on a lot of systems. So all I have to do is save it with the global variables, including ready already, equal to this constant. And then there's a small chance that the constant already would have been there just by coincidence from some previous TeX run that had gotten loaded in the same place and the loader hadn't cleared it out, I suppose. But that's the chance that I'm taking there. Okay, now I explained all of that, and What else is there to talk about for initializing? Any questions on this? I would say the major part of the debugging that I've done has been in arranging these things at the very beginning and the end of the program, so that they will handle unusual, exceptional cases that I didn't think of when I first wrote the program. The guts of the thing inside, where it's doing syntax and semantics and so on, that's all clean computer science, and this other stuff is hard. And I think it's getting close to being correct there. Okay, now there's one thing that INITeX can't do, and that is load a format file. INITeX always, I guess it has to load the string file, the string pool, and there's no easy way for me to tell it that I wanted to load a format file instead and start from there, so I just didn't build that in. I have to fake it now as I'm debugging the thing. I stop it with the debugger at the point where it tests if format ident equals 0, and format ident is a variable inside the program that INITeX initializes. In INITeX, there's the assignment format ident is set to quote INITeX in parentheses, I guess. And otherwise, it's a variable that's set to 0, and then INITeX sets it to the name of the format after preloading a format. Like it'll say basic of July 28th, 1982, or something like that. So format ident is set to non-zero at this first part of the program only if I've got INITeX, and so in order to bypass that, I stop my debugger at this line where it's going to test format ident for 0, and I reset format ident to 0 using the debugger ability to set variables, and then it goes through, and I pretend and I have a vertex for debugging, but it has to be done with change files otherwise, and I guess that's okay. I don't see that I ought to have a special test in there, but I might think of something that improves that by the time this thing finally gets released, since otherwise INITeX can do everything. The code is there to load the format file. There's just no way to get to it unless I change format ident manually. So that's the way I've been doing it as I get the thing started now. Let's see, DVI server. Okay, I think I've covered the main points that I wanted to make, and so I'll open up for all other questions answered. And if these questions want to focus on another part of the TeX program, then I could try to answer questions on that.
Can you use dump with vertex?
If you say dump with vertex, you get into the error message shown in module 1190. Where is it? Okay, dump and end come out with the same command code. And so as far as most of TeX is concerned, end and dump are treated identically until you get to module where? Okay, module 1203, right. And C is set to curchar. This is the final cleanup procedure is what's called at the very end. And C is the curchar, which is either 0 or 1 if it was end or dump. At this point, it checks to see whether you have a name for your log file or whatever it will be called. And interesting algorithm there to eject the remaining pages. I guess I ought to talk about that a second. And then you check to see whether or not we've finished all the groups that we were in. But then there's this test. If C equals 1, then in init, we will do a store format file and return. But if that's commented out, we get to this error message that says you lose. I mean, it's just another thing in parentheses that can happen at the end. Everything else goes on the same. So it ends, but it doesn't dump. And that's because there's a heck of a lot of code just for dumping these files. It starts on module 1167, and the dumping and undumping are presented in parallel. First you have a dump module, and then you have an undump one to load it again. And you can see the parallelism between those. But we sort the available space list and do various things like that we just soon have commented out in the production version of TeX. Now this what happens when you end? That's something. There's an end game. I've heard a lot of people who have lost pages. You know, they had a figure that was carried over to another page, and at the end of their job, and they never got to see that page. Somehow it ended in their typesetting system forgot about that one. It was floating insertion, and it got floated all the way out to the end. And it's possible in TeX, you see, to write general output routines that absorb information but don't print it, and then they might change to another output routine, and all kinds of things can happen. So what are we supposed to do with something like this? How are we going to know that the output routine hasn't been stashing away this information for some future thing? Well, what I do actually is in module 1204 there. So I call build page, which is a procedure that it empties everything out that's already been contributed to the first page, and calls the output routine if it's time to do so. One of the things that would cause it to do that is if there's a forced page break, penalty of negative 10,000 or less, would cause a ship out to occur. However, ship out doesn't occur on empty pages. Now, output routine to get fired up except on empty pages. Well, then I check and see if page head is equal to page tail, in which case I'm happy. Now, page head and page tail, that says how much is there anything left on the current page? If not, then I figure I'm done. So the output routine then didn't leave any residue, and I figure I'm done. Otherwise, I put in a null box, and I contribute a null box whose width is the h size, and then I put on an eject penalty, a forced break penalty, and I do that up to 25 times until finally the output routine has ended with nothing there. I hope that works. If that doesn't work, I'll have to think of something else. But with luck, that will work and get the last page out. Anyway, right now I propose that that's really going to be the definition of the end game for finishing up a TeX job. If I just put out a penalty all by itself, then it wouldn't necessarily invoke the output routine. But if by putting out a box followed by this eject penalty, then I'm sure to invoke the output routine, because putting out a box starts out the page and says that the top baseline skip is put on there and all the other things that the page is not empty, and it's guaranteed to invoke an output routine. If I just made that box a null box, then I would get an output routine that has a column width of 0. And this has led to bad results when your output routine is trying to build up 5 columns of stuff, and you give it a couple of null boxes, and so then these 2 columns stretch out over because you've got null box over here instead of being the right width. So I make this box that I put out there, I make this box have the correct width. But I think I have the wrong test here, because I should really not just check page head equals page tail. I should also check that something was shipped out, because it's possible the output routine would have absorbed something and not shipped it out. So I'm going to make this a little more complicated in order to fix that. Yeah, that's right. It's nothing like trying to explain something to somebody in order to realize that it's not working. Question?
What happens if you make an insert, several inserts to the same box?
They all get concatenated together until one of them has to split, and then future ones are bypassed and carried over to the future. That code has been fairly well checked out. That's what I spent most of my time on debugging, and that's in the two parts called breaking vertical lists into pages, and the previous one is, let's see. Breaking vertical lists into pages is part 43, and then the page builder is part 44. And those, it spells that out in some detail. But it's this is what I call the researchy part of TeX, and I think that's in fairly tight shape here. I haven't debugged the paragraph builder yet at the present time, but this part of the page builder I have gotten, I think, correct.
What happens if your output routine just takes whatever it gets in box 255 and ships it out? Will your eject the remaining pages just keep on spewing out paper?
No, it only does that. You see, a ship out would only occur on an empty box, and I would want to also turn that off. Yeah, I got to find a good termination condition for this. It works fairly well in the present TeX, so all I have to do is convert that to this one. It was similar, but not the same, so I better do that again. I remember going around about 6 times on the present TeX too to get that to work on multi-column output. The problem is if you're saying putting 5 columns on a page, then your output routine has 5 steps to it. And so you finished the second column, and then end came along. What are you going to do? And you want to give the output routine something to do until it reaches a state where it actually does a ship out. And then I think we're done, maybe. Unless it gives you, no, and then it might put something back on the contribution list, which would mean that it still wants to be invoked again. But let's not solve that problem online. Is there a question on that side of the house? Somebody said, what about the availability of these tapes? These tapes are going to be rented, I suppose, just like the previous TeX classes were done, and I'm going to try to get 2 copies of these tapes, one to be kept at Stanford and one to be kept in Providence. They'll be the property of the TeX users group. Please use your mic. But I don't like that kind of question. How long do I expect before X? These kind of questions are verboten. I mean, as soon as I can. I'm having a vacation, though, too. I'm going to collapse tonight. Yeah.
You were going to mention something about rounding on low-resolution devices?
Yes. Rounding on low-resolution devices. Yeah, good thing. We want to... After looking at this problem for some time and discussing it, we think we have a fairly good solution to the question of how to make reasonably high quality on low resolution without and still at high resolution. Now you have a problem that I could say this way. Suppose we have a 10-point font. My original 10-point font was working on an XGP printer who had a nice feature that exactly 2 pixels per unit in the font. So there were 36 pixels in a quad, and all of the widths were based on monotype widths. So they were integer number of units, and so everything in my 10-point font was an integer number of pixels. The n would be 10 unit characters, so it would be 20 pixels wide. Now, what about 9-point then? That meant that each of the units in 9-point font was 1.8 pixels wide, and so I'd be setting a word, whatever the like, what's your favorite word? WORD, and and my original implementation, the very first one of TeX, I rounded for every character. So I computed the exact position where the character should start, and then I rounded so that this 9 points would eventually get there would be a build-up, and all of a sudden we'd go back 1 pixel wherever that would happen to happen. And so if word would occur here, a little bit to the right, the glitch of where the thing shifts would take place at yet another place. Now that wasn't too satisfactory, but we didn't mind because we used mostly 10-point type, and this was just for proof quality anyway. But then we started to see that people actually had low-resolution devices. They wanted to send out on their letterhead. They were using this for correspondence and everything, and it was supposed to actually look fairly reasonable, even though it was coming out of a low-resolution device. And then we said, well, okay, a font designer can tune the design of letters so that each character width is an integer number of pixels, but then it's not machine dependent. It's not machine independent, because if you write the TFM file and it's only good on a machine that has a pixel width of a certain kind, then how should you have the same font on another phototypesetter? So what's a good solution to having your cake and eating it too? It seems now we can actually do this fairly well. Meanwhile, we noticed that there were people writing DVI drivers here that didn't know how I had rounded every character, and they decided that they were going to only round at the beginning of a word. And that looked pretty good. You see, wherever you started, then you would use the pixel width of the character and continue along with the pixel width until you got to a new H-skip or something that would take you there. So this meant that the font designer, even though the TFM file had true machine-independent widths in it, the font designer could also tune it so that the sidebars would be nice for the spacing of the letters in a word. Now, in TeX, we have kerning in order to improve the quality of the output. So I don't know. I think maybe between R and D there's a kern. I'm not sure, but let's suppose for the sake of argument, no, W and O I'm sure there is. There's a little kern that brings the W and O a little closer. Because I'm pretty sure W, because X and O do. And so a half a unit closer spacing is there in the DVI file. So between the set W and the set O command, there's a right by minus a few in the DVI file, which brings the letters a little closer. This meant that these algorithms that were starting at the beginning and then only doing a correction after glue would make this correction at the point of a kern. So we'd be setting along a 10-letter word, and if we have a kern right there, then there would actually be a recalculation, and the rounding error would be the glitch would occur at this point. Well, as a result, kerns were causing the quality of the output to get worse instead of better. They were intended there to make refinements that would help, but actually they were causing the rounding to occur at that point and spoiling it all. Well, we don't want to take the kerns out of the formal font definition. We want to use exactly the same TFM file in both cases so that our lines will break the same when we're printing on the high-resolution device. We want TeX to do all the calculations the same. So what's the answer on the DVI file? And the answer is that we round after we make a large jump in horizontal or vertical direction, then we round. Otherwise, we do all our calculations relatively. So the font, so when we're not making a large skip, and large skip is defined as a certain percentage of the current M in the font, I think it was, then we will just stick with pixel widths that come either in the pixel file or that we could get by rounding the character width to an integer. Now the Metafont programs have a char width command where you say that what the char width is in points, and this might be W. And then Metafont also has a char device width command, which is generally given as round of pixels times W, something like that. In the typical use of Metafont, this is what we've been doing, and this device width goes into the pixel file, or well, it's used to decide the width of the characters with its sidebars. Now, the actual width of the character we found in refining fonts. We want to fiddle with this and not use this value exactly every time. On the letter M, for example, it turned out that if we wanted to get this distance to be the same as this distance, we would like the M to be one pixel more or 1 pixel less. Then we would calculate by taking 15 units and rounding to the nearest pixel. So we could make that kind of adjustment, and then anyway, the width that's actually there in the character file could be used for the typesetting process. The moral is then we have a register H and V for our horizontal and vertical coordinates in DVI units. And as you saw in the printout there, H was large and so on. Then we also keep registers HH and VV, and these are kept in pixels and updated locally. And only do you set HH to be the rounded value of H when you've made a big jump. In the vertical direction, the problem was not for within a word, but for fractions, like 1/2. We wanted 1/2 to the spacing between here and here to be about the same no matter where this appeared on the page. And we chose the definition of a big jump so that this would not cause big jumps in a fraction like 1/2. But so that for getting from one line to the next line would be considered a big jump. So all the vertical spacing in here is relative to something that would be rounded the same no matter where we started from. So VV count. So in other words, we're taking calculations like VV is set to round of V after big jump, but it's set to VV. It's set to, okay, suppose we're doing a V is set to V plus A. Then if A is large, we do VV set to round of V. Otherwise, we set VV to VV plus round of A. Or round here, I'm assuming it includes the factor for getting to pixels. So here's a relative calculation for small jumps and a big calculation and that's where the rounding error ought to accumulate in the big jumps, because that's where the eye isn't going to see it. So a simple solution, but took us a while to find it. Now that solution is implemented in the DVI type program that we passed out as a model for how we propose to do this kind of typesetting.
You were mentioning the existence earlier of an allocate function for things like dimensions and boxes and things like that. Is that going to be part of the basic format?
Allocating function for dimensions and boxes. I'm sorry.
So that if you need a new dimension.
Oh, yeah. Oh, thank you. Yeah, basic is going to contain something like get font, get count, get demand, and then it will return to you a symbolic. It will return to you a number that hasn't been used before, so that several people can be. So if you want to define a box, then you can. Then you can get one. I believe that it will be a rather simple-minded macro. It's not going to keep a linked list of the available ones, but it will probably assume last in, first out if you are leaving them back in there again.
Yeah, I just want to say one thing about the rounding problem, because we faced almost exactly the same problem writing the driver for our device. Well, we did almost exactly the same thing, except we would compare the size of the indicated motion in DVI with the size of the error that we developed. And we'd pick up the error only when the size of the indicated motion was somewhat larger than the accumulated error, rather than using a fixed dimension, saying that if the motion is bigger than this, we'll always pick up the error here. We compare the two. And so if you accumulated a very large error over a word, you would not necessarily pick it up all at once on the next space if that would wipe out the space.
That's interesting. We should talk about that. Maybe that'll work out. Yeah. Okay. We were hoping that the error wouldn't ever get that large. That there should. We were assuming that this that the device width compared to the width would never really exceed 1 pixel, or certainly not 2.
Actually, on our machine, it turns out you see 1 pixel entirely too well, because we, in fact, had our first driver do exactly what you had there with the kerning. And you definitely noticed when a kern all of a sudden wasn't there.
Right. Yeah, I had a difficult time, again, with that word different. No, I guess it was different. But in the tech manual that we printed on the Dover, I was trying to illustrate what happens if you'd use kerning and not use kerning with the word and the way it was rounding, it was actually going the wrong way, and the unkerned one was coming. So I had to add a couple extra words to the text in order to get it in the right position on the page, so that this would happen. I've never admitted this before.
Also, one other thing that sort of was curious about this, when I first got into this, I wrote in my driver a little thing that would send out what is the error, how much different is what tech thinks the width of the character is than what the character actually is. And I was using your old computer modern fonts. And I began to get the impression that you would tune them for a certain machine when I was getting half a pixel error on almost every other character coming along. Almost everything was the worst possible case.
Yeah. Okay. Well, the currents were you see, the machine, the resolution that I was assuming in my first design was 252 to the inch, which is somewhat close to yours, and my currents by a half a unit would be about a half a pixel. Yeah. Question here.
What's the status of debugging on DVI type?
DVI type is, it seems to be working, but I just had DVI file to test it on as of last Saturday. And so right now I'm willing to pay $1 for every bug to the first person who finds a bug in DVI type. I'm willing to pay $1 for that, and that'll go up to $2 after a few months. So if you really want to hold off and gamble on it, you could. But otherwise, if you think you've got one, you could send it in, and gratefully I'll pay this. Yes.
Could you give us an idea of what your plans are for Metafont?
My plans for Metafont are just to do for it as I did with Tech. Go make a new version, considering what users' experience has been, to incorporate what seems to be better ideas at that time. We're going to experiment with changing changing a few things. We're going to see if conics would work as good as cubic splines. We're going to experiment with trying to find an intersection between points. We're going to experiment with one thing that looks definitely we're going to do is make D-draw with pen of size 1 to be very efficient. It's terribly inefficient now. And it seems to be very important for lots of kinds of fonts, calligraphers' fonts. So that's going to go in as right now. D-draw means filling in between two curves. If you have a pen that's reasonably wide, and you want to fill in between this curve and this curve, Metafont will draw enough things in between that so that, given the thickness of the pen, it'll tend to fill in. I think it gives a factor of 50. It figures the radius of these, and it chooses these points so that they shouldn't be more than so that they should overlap, and actually with a little fudge factor in there, so that you got twice as much tolerance as you ought to have. And so only if the curve is real wild will you have a hole in there. Well, so it fills in with this real crude method, just reduces the filling in problem to a sequence of the other things. Very slow. Now people have been wanting to make very sharp images so that this pen is 1 pixel wide. And that means that I draw all of these things over and over again. It's very, very slow to fill that all in. And but it's a trivial problem to fill in between 1 pixel wide things if you say to yourself that problem. Well, the new Metafont is going to not use the bit representation of the raster, but it's going to use run length representation of the raster, all integer variables. Pascal doesn't have convenient operations for sets. You can't take the intersection of two sets or the union of two sets or shift the two sets the way Algol W could. I don't know why Klaus left it out, but he did. And but anyway, it's probably going to lead us to better algorithms where we work entirely with arrays of integers to represent these patterns inside the memory. We'll be able to get by with memory that grows as order n instead of n squared, where n is the resolution. So the coding will do that, and there will be some changes to the language, but I don't want the language to get real Baroque. There's so many more things you could do with Metafont than you could do with TeX even. So I don't plan to add elaborate control structures or data structures to Metafont. We'll make it easier to use arrays, but not record structures, for example. Target is that I'll be doing that, winter quarter, January, that I'll be working on that program. My future plan is to have 3 books done that are going to be a series called something like Computer Typography, Volume 1, 2, and 3. And Volume 1 is TeX, Volume 2 is Metafont, and Volume 3 is Computer Modern Fonts. And that's my plan is that this will be my contribution to what I know, what I've learned about typography, and I'll feel justified at that point in leaving the ball to other people to see if any of those ideas are worth carrying on or not. And I'm going to write Volume 4 of The Art of Computer Programming after Volume 3 of Computer Typography, and continue working on algorithms, which is something I know I do well. You had a no, you don't have a comment.
If through Metafont you generate a few characters, how immediately you can typeset it and see? Because the spacing between the letters is very important. So letter design doesn't mean only the separate letter, but how does it really look when you put it side by side?
Yes.
So when we design things with Metafont, we have been having a new mode that we've been building into our format files called smoke mode, and it prints out a rather large version of characters with corners on them as to where we've currently designed it, and then it'll have the character image there. And we call it smoke mode because this is the way people in the old days would make their fonts. They would have to work, of course, at the actual size with their little files and get the letters, and then they would take the smoke of a candle and put it down on the paper and trial set until the thing looked right. So our smoke proofs are things that we do. We don't work at the real size though, so we have to have these, and we put these corners on so we can set several of them in a row. Then we go back and we look at it from down the hall as far as we can go in order to see how it looks, and until we get something that seems to be good. Then we typeset a few words and make further corrections at that time, because the eye plays these things optically change when you vary the scale. You have to try to work at the true size, but you have to also work at a large size when you're doing the design. This is all another story, but very interesting one.
A remark on that same point that's interesting, at the Mergenthaler font design group, our drawing shop, they have a useful tool for that process you just described. They keep a pair of binoculars, which they use backwards. In about a 20-foot room, they can get a view of the character.
This is it's very important to get to be able to see these things that you can't do otherwise. And oh yes, the subtleties in font design are much underappreciated by the world, and I'm trying to use Metafont to capture some of those subtleties into a program so that at least we can see in a precise language what they are and not just talk about them by hand waving. The computer modern fonts are being criticized by people that I think are the best in the world at these fine details, and although I don't have the right artistic temperament to design the most beautiful fonts, I'm at least going to have the hooks in there that indicate the right kinds of concepts, and this should help the real artists of the world to indicate what the new fonts should include. The kind of subtleties will be recorded. The intelligence of a font design will be in there, not just the drawings. That's my goal. See what happens. Well, that's the look to the future. Now, well, I'm going to take one more comment from, and then we'll have to wrap this up.
It would be sometimes when you write documentation, you want to look at it on a printed page where it's all nicely typeset and everything. But it would also be nice to be able to look at it online. Are there any plans for having the output of TeX be able to be read on a line printer or on an ordinary terminal?
Yeah, well, right now we have DVI to data disk and DVI to Sun terminal working at Stanford. David Fuchs's thesis will be on interactive versions of TeX, where you see the thing immediately as you're typing it in. I don't know right now of anybody who has taken TeX output to a line printer. There was an experiment, fairly successful, of another language to line printer in, was it Manchester, I think it was. And there's a report about that in our library. I can't remember the Anstey or something. No, I don't remember the name of the author. But they would set things on a few. You had to get used to reading the output, but you could. I mean, it somehow indicated, even on a line printer, what the bold and the italic were in a form that people felt they had for proofing. I find that TeX users get to after a little experience, they can see in their mind what they're typing pretty well. It's only that they won't know how many lines a paragraph is going to justify to, but they'll have a fairly good idea as they're typing a math formula that it's going to work out all right. It's something like we went to the newspaper office to see the people who typeset the classified ads, and they are working with a very primitive terminal, has only uppercase letters on it, and you ask them, well, wouldn't you like to be able to see the bold face on this, see things centered and italic and in different fonts as they're going to appear? And they say, well, why? We know what it's going to look like. They do this all day long, and there's no problem. They don't need that kind of feedback. But and so a user who the first day wants to see what an integral sign is going to look like and where its subscripts are going to go and things as he's typing in. But the second day, you just type int, and you know it's going to be an integral and going to look all right with high probability. You get a picture of what that's going to be. This need for quick visualization isn't any more the same as the initial user, but you still have it at the end when you're making final polishing on a manuscript, because all of a sudden somebody's pointed out an error on page 38, and you've got to fix that paragraph, and you want to make sure that your fix doesn't make that paragraph any longer so that it's not going to mess up page 39. And at that point, you want an interactive version of TeX, and you're going to play with that paragraph until you got it not only correct, but also the same number of lines as before. So when I was doing volume 2, I was very heavily using our XGP synthesizer program, where I would typeset a paragraph, and then I would check it and see if it was coming out okay. I did that about 20 times, at least, for last-minute corrections, not only errors, but new, late-breaking news and things like that I wanted to get in the book. So I really believe that this is a necessary thing that more software should be devised to handle. I also look forward to programs that will display modules in a web system that, as you're debugging, it will just format the ones you need at the time. Each module is really formatted pretty much independently of all the other ones in self-contained unit. And when I spend a terrific amount of time to reweave a whole listing, that's because I'm producing a thick listing. But if I'm only going to look at a few pages of that listing, then selectively I could be doing only a few parts. So a lot of different software can be imagined that would make such systems as we've got now that much more powerful. Yeah, great deal needs to be done yet, and I'm thrilled to see so many people listening to all these lectures. That we have this experiment going now in portable program. I don't know of any other instance of where there's going to be so many people understanding a program of this complexity. So this is a new territory, and I think we're all in it together, and we should have some exciting times ahead. With that, well, you have a final comment? What is this? I'm never going to be able to...
On your Weave program with your TeX82, I just have been glancing through it. I noticed that you managed not to break any of your modules on page breaks. Did I miss that, or?
Oh, there's probably somewhere in the DVI description where there's so many opcodes that it does that. But I tried to keep modules short where possible. But there's a ragged bottom in the Weave output, and there's a easy way to do that with TeX to get ragged bottom. Will be explained in the user manual. So have a good time.